This is an instructional video of a ChemCollective's virtual lab dealing with acid-base equilibria. In particular, we are going to try to determine the concentration and the dissociation constant of an unknown weak acid and weak base using a pH titration curve. And so first, you have been given a write-up, and we will follow this link in your write-up that will shuttle us directly to our virtual lab. And so this is the ChemCollective's virtual lab. And this in particular is the unknown acid and base problem. And what you see here is on the right hand side, I have a workbench that is simulating your bench top, or what should be your bench top. And on the left, we have the stock room, which holds all of the chemicals and glasswares and any instrument you would need for a particular lab. And so for this particular lab, we are going to be determining the Ka of an unknown acid and its concentration, and the Kb and Ka of an unknown base and its concentration. And so we can start off with the acid, and so I will take the acid, the unknown acid, from the solutions menu, and now you see that the unknown acid, a flask of the unknown acid, has been brought to my workbench, right? And you can see that we have in our stock solution of unknown acid, we have 100 ml of unknown acid in our flask, and so we will be doing a titration. And so what I would also need is a titrant. And so we will be using a strong base as the titrant, and we will be using the 0.01 molar sodium hydroxide solution. Again, you can refer to your write-up for the exact chemicals that you would need. And so we have our unknown acid and our titrant, and we need also an empty flask with which to do the titration. And so an Erlenmeyer flask is the best for that. And you see we have three types, and I will take the smallest, the 250 milliliter flask should suffice. And we will need a way of transferring the stock solution, some amount of my stock solution, to the 250 milliliter flask, and so we need a pipette. And so there are pipettes, and I will use a 10 milliliter pipette. And now for titration, we will also need a burette. And so I will take a 50 ml burette, and so the burette is going to be located in the other menu. But you see here that it says my workbench is full. So this program is really finicky with the material that you have placed on your bench top. So it doesn't like a lot of clutter, and rightfully so. The best bench top is a uncluttered bench top. And so let's see if that helped. It wanted to do that anyway, I think, but I wanted to force this because I know some of you might come across it, and I didn't want you to panic. So let's try this burette again. And it doesn't like where I placed it, so let's see. I'm gonna put it here. Nope. See, probably should have left well enough alone. Let me see. So you see, I mean, it just takes some fooling around and rearranging with your bench top, but eventually it will work out. And so the last thing I need for this experiment, for this titration, is going to be an indicator. Because I want another way of determining the endpoint of my titration. So we will be following this titration by pH, but I also want an indicator to let me know when the titration has reached its endpoint. And so for weak acid, so the indicator would be under the solutions, right? It's a chemical, it would be under solutions. And so for a weak acid, I will use probably phenolphthalein is good. And so I have that. Okay, so now I am ready to prepare my titration. What I'm gonna do is what I'm gonna have to do is transfer some amount of solution from my stock solution, right, from my unknown acid stock solution, and to put it in the 250 milliliter flask, and I'm gonna use a pipette to do that. Notice that my stock solution has 100 milliliters of solution in the flask right now. And so the way I'm going to use the pipette to transfer is I'm going to drag the pipette and hover it over the flask, right? My stock solution of unknown acid, and let it go. And you'll see that when I've done that, you see that plus sign. That plus sign is showing that we're trying to use these two equipments together, right? So you see once it hovers over, you got that plus sign, you can let it go, and now you see that it's set up to work together. And a new window has opened asking us what volume are we either taking out, withdrawing, or pouring in. Now obviously we're going to be withdrawing from this flask, right? And so you can see here what's done is there is a magnification being done of the graduation or the graduated part of this pipette. So this is a graduated pipette. So in reality, this pipette can only withdraw 10 ml. This program is not that finicky, but normally a graduated pipette would only be able to draw the amount of volume that the gradation is for. So this is for 10 ml. And so you can see that the pipette now is empty and we have solution in our flask. And what I'm going to say is I want to withdraw the capacity of this pipette, which is 10 ml. And I'm going to withdraw that 10 ml. And once I click withdraw, you can see now that the solution, this was like transparent, but now you can see the grayish liquid that was here is now here. And in the magnified part, you can see how the solution has a meniscus that is nicely covering the gradated part of the pipette. Notice also that we have some information here on the side telling us some information about the solution. So the solution is 3.20, it has a pH of 3.29. That's going to be important, right? That solution is also, when I click on the flask, right, it tells me the properties of the solution in the flask. You can see that the pH of the solution in the flask is 3.29, as of course the solution in the pipette. Notice now that the volume of the flask is reading at 90 ml, right? We've decreased the volume of this by 10 ml. And so now I'm going to take this pipette and I want to transfer its contents to the empty 250 Erlenmeyer flask, which is empty, right? 0 ml. Now you see as I'm hovering over it, I get that plus sign and I can now let go. And my pipette still has the 10 ml of solution that I withdrew from the stock solution. And now I'm going to empty it or pour it into this empty flask, and it's asking me how much, and I'm going to put 10 ml. So notice also that the units of this are default to ml. So this is only in units of ml. And so now I put in my volume and I'm going to pour that volume into my empty flask, and you can see now that my pipette is empty and its contents have been transferred to the 250 milliliter flask. And so I now have my flask of the unknown acid, 10 ml of the unknown acid. And here on the side that we can see that the pH is still 3.29. Right now, what I want to do is add some indicator, because again, I want some way of visualizing the point, at the point that I'm at my end point. And so I hover it over again, and again, it's asking me for a volume. Now, you see that this is a dropper. Normally in the lab, we would just be able to use that dropper to put 2 or 3 drops. There is no option to put drops. We have to put in a volume. So I'm going to say that 1 drop is 0.1 milliliters. And so I'm going to put 0.1 milliliters, and I am going to simulate adding a drop, and by pouring 0.1 milliliters. And when I do that, see now that the volume of the flask has gone from 10 ml to 10.1 ml, because now there is 10.1 ml of solution in this flask. So that was 1 drop, but I usually add 2 drops for titrations, and you don't need any more than 2 drops, but 2 drops is nice. So I will click it again, and now you see that the volume has gone up by another 0.1 mil. So in total, we have 10.2 milliliters in this flask. And now I am done with my indicator. And notice that my pH has gone up a little bit. It was 3.29 and now it is 3.30. It went up by a factor of 0.01. That is because the phenolphthalein has a pH of 6.4, so it's a little bit higher. And so it increased by 0.01 the pH of the unknown acid. But hopefully that should not drastically affect our results. So in any case, what I want to do is, a lot of times, and it should normally be that we would use 3 trials and to do titrations and take the average at the end. We probably won't do 3 trials for this lab. In a simulated area like this, you're using the same numbers all the time, so there is no reason to use 3 trials. But let's say I did want to use 3 trials, or more to the point, if I just made an error and I needed to redo the experiment, rather than having to do all the additions again, what I can do is just duplicate this flask, and therefore I can have 3 flasks to do 3 trials, or I have 3 flasks to have 2 backup. In case I make an error with this one, I can redo the experiment with these 2 and not have to waste time refilling the flasks again. Okay, so now I have my 3 flasks, and what I need is my titrant, right? So I have my burette here, And this is a 50 milliliter burette. And so I am going to hover my titrant, which is the sodium hydroxide, over the 50 milliliter burette. And now again, I see that it's asking me for a volume. So notice here with the burette, it's showing us the magnified portion it's showing us is here on the bottom, the 50 ml. So here on top will be the 0 ml mark. And I want to fill this to its capacity. So I want to fill this burette to the 0 ml mark. And so I will say that I want to add 50 ml, right? So I'm going to pour 50 ml in this. And what you see now is that the solution has reached to the 2 ml mark. The reason for that is remember that the gradated part starts here somewhere. There is a volume, there's an area beneath the 50 ml gradation that is not gradated and or not graduated. And so, oh, I lost my flask. Let me put that back. And so some volume of my sodium hydroxide has gone here, right? So there is some volume here that is being taken up by the sodium hydroxide. And so we actually we don't have enough to fill up to the 0. What we actually need is actually 2 more milliliters to get to that 0 mark. So I'm going to add another 2 ml. And when I do that, you see that I am now at the 0 mark, right? And so I can now remove this. And now you see that I've removed 52 ml from my stock sodium hydroxide solution. So now there's only 48 milliliters in here, but there is 52 milliliters in my burette, but 50 of which, remember that we only can measure between the volume removed between the gradated regions, right? So now I am ready for my titration. So I will hover my burette over the flask that I am going to titrate, and until I get the plus sign, right? I got the plus sign, so we are ready for the titration. Now, the question is, by how much volume do we want the increment? What volume increments do we want to use to do the titration? And so what I'm going to do is I'm going to start with increments of 1 milliliter. And what we should notice, remember, first of all, remember that we are following this titration by following the pH. So it's very important that we get the initial pH of the unknown acid before the titration, before we start the titration. So at 0 ml. So I'm now selecting the flask, and we see that, like I said before, the pH of the flask is at 3.3. And once I hover now I'm selecting the burette, right? So it's showing the reading of the pH of the burette, of the solution in the burette, of the sodium hydroxide. And so I'm hovering, and now we're using them together. It's still showing the pH of the solution in the burette, but once I start the addition, it will switch over to the measurements of the pH in the flask. So I'm going to go by increments of 1 ml, and I am going to now pour the 1 ml. And so what we see happening, right? So notice the pH has changed, of the flask has changed from 3.3 to 3.68. And here it shows that the volume of the solution, right? The volume in the burette has decreased by 1 ml. And the volume of the flask has increased by 1 ml, right? It was 10.2 milliliters. Now it's 11.2 milliliters. And so we've added 1 ml. And what you want is for each volume added to note the pH at that volume. What you also want to be careful with is you don't want the pH to increase by too large of increments, meaning that you really want the increments that the pH increases by to be less than 0.3. I mean, 0.25 is good, is probably best, but any more than 0.3 can be a problem, because what we're trying to do is to plot this curve, to plot this data, and a pH increase of more than 0.3 will leave a large region of unplotted a large unplotted region, which will not be helpful in us making a smooth curve. So so you really want to make sure that the increments stay below 0.3. So now here the increment was a little bit above 3. And for the beginning, and only the beginning, that will be okay. Because right now what you'll see is as I keep adding, the increments will go down, right? So I'm pouring. So I'm going to pour another 1 ml. And you see now that I went from 3.68 to 3.93. So that's about a little less than 3. So that's okay. And what you'll see, a little less than 0.3. What you'll see is as I continue pouring, so I'm going to pour another 1 ml. So we're at 3.93. And now it went to 4.1. So it's about at 0.2. So that's good, right? That's good increment. And remember that we will, at each volume that we add, we will note down the pH. And so I'm going to pour again. So we went from 4.1 to 4.23. So that's an increase of 0.13. So that's okay. And so we can keep with this 1 milliliter increment that we're adding. Remember also that you are noting the pH at every volume that you add, right? And so again, so that was an increment of about 0.1. And we're going to do again. And that was again, right? The increment by which it's going up is decreasing. So now it's increasing in increments of about 0.07. So very small, right? Which is what we want, right? And notice that the volume here is, so far we've added 7 ml, and there's 7 more ml in the flask. And I'm gonna pour more. And now notice that the increment has just gone on by 0.06, and I'm going to again, right? So the increments is actually good. It's going up by small increments, so that's good. And so I can keep adding, but remember that you will be noting your pH. Don't forget to note the pH at each volume, because otherwise you're going to have to start it all over again. Okay, I'm going to continue. And so that was an increment increase of 0.06. That was an increment increase by 0.05. And we are continuing with this 1 milliliter increments of addition. What you also want to remember is we have an indicator here, and that indicator should change pink when the solution has hit its endpoint, hopefully. So let's see. So we're at 4.8 and now 4.85. So the increments that the pH is increasing is still fairly small. So we're still good with 1 milliliter increment. And that's okay. So, and again by 0.05. So I keep on adding. That went up by 0.04. And I'm keeping on adding, right? That was 0.05. That's 0.05. I'm going to keep adding. And the increments are still fairly small. That was 0.04, right? Still going up by 0.04, so 1 ml is still good. That was by 0.04. That was by it went up by 0.05. Still going up by about 0.05. Okay. We're still going up by 0.05 increments. So, I mean, increments of 0.05. So 1 ml is good. That was 0.06. So we might be increasing the amount that the pH by which the increments are increasing is getting a little larger, right? So we want to be careful now. So that went up by 0.05. Ooh, that went up by 0.07. Okay, but that's still okay. Remember that as long as we're below 0.2, 0.3 to 0.2 to 0.3, we're good. All right, so that was 0.07, right? That was 0.08, so it's definitely the increments by which the pH is increasing is getting larger. And that was 0.09, right? So we really need to start getting careful now. That was 0.11. So now the increment has increased by a little over 0.1. So we want to be very, very careful. I'm going to go by 1 ml again now. So now it increased again by like 0.1. So I will go by 1 ml one more time. And that increased by 0.2, right? So that's it. I am decreasing the volume that I'm adding now. I'm going to go by increments of 0.5. And hopefully that will decrease the amount that the pH will go up by. But also remember that we might be getting near the end point. So we want to see when this flask is going to change to pink. So that went up by 0.13. So that's still okay. I can probably do another 0.5, but remember, we don't want it to be too much more than increased by too much more than 0.2. So that was about 0.2, right? So I'm going to take this down again now. I'm going to take this to 0.2. And let's see. I'm going to pour it. Right, so that was 0.1. Now we're not going to decrease the increments below 0.2. The reason for that is, in reality, if you use a burette in the lab, it's going to be very difficult to get gradations to remove or to get the accuracy of removing less than 0.2 milliliters. Really, 0.2 milliliters is the best we would be able to do in a real burette in the lab. So 0.2 is fine. We're going to continue with 0.2. And just remember that as you're adding volumes, you're also noting the pH that is being measured at that volume. And so I'm going to add 0.2. And that went up by more than 0.1, right? But that doesn't matter. What we're interested in more now is what the pH is at every volume that we are adding. And we are also paying attention to the color of the flask. We want it to be, when it turns pink, it will be at the end point, right? And so I now added another 0.2, so it's going up, right? And it's going up by 0.3, but it's okay. We're gonna stay with this with increments of 0.2 ml. Wow, that was a big jump. Did you see? But that's okay. That is why we were using such small increments of volume, right? Because we wanted to make sure that the jumps that we get are not going to be that big, that large. I'm gonna keep going, right? Noting also the color of the flask. So notice now this flask, and if you didn't notice, you should maybe rewind the video to see the difference. It has now become pink, right? It is definitely pinker than our stock solution, right? So it has turned now pink, and so we've reached the end point, but we will take this to a pH of I'll try to get to 11.5. If we get to 11.5, that would be good. But anywhere in the range of 11 would probably be fine. So again, I'm going to use 0.2 increments until the pH increases by very small amounts. When it does that, then I'll start increasing the increments of volume I'm adding. So I'm gonna click again, and so that was again like 0.3, right? So the jumps are not that large now. I'm gonna do this again. So that was about 0.2, right? And another 0.2. So again, so now the increments are getting fairly small. So we're at 10.16, 10.26. So that was like a 0.1. I'll do it by 0.2 again. Right, so now it's below, it's like 0.08, right? So that's about 0.07. So now again, we've reached the increments by which the pH is going up is by about 0.05. And so I can increase this now, increase the volume that I'm going to add by 0.5. And so, okay, so that was good. It's going up by 0.08, that's fine. Right, it's not going up by so much anymore. So that was an increase of 0.05. So let me increase this to 1 milliliter again. But also notice you want to pay attention to your burette, right? Because your burette is about to become empty. We're at 46.3 ml that we've added, so there's not much left, right? So now we added another 1 ml. So the pH is still going up, but it's still not at 11. We still have more, so let's pour another 1 ml. And now we're at 11.03. So let's use the full capacity of the burette. And so I'm going to take another 1 ml. So I'm at, you see, it's really not going up by so much. So that's 11.08. I don't have 1 ml to add. What I'm going to do is I'm just going to add another 0.5 ml here at the end. And that takes me to 11, pH of 11.11, which is fine, right? And there's still 0.2 ml left in my burette, but that's all right. That 0.2 ml is not going to do much. And so I'm going to remove that. And here I have my titrated flask. And what you should have done, right, as I was telling you, as you are adding volumes, you've accumulated all these measurement data of the pHs at each of those volumes that you added. Now, if you've made a mistake, you have what you can do is empty this burette. So it shows there's two removes. There's this remove, which removes the entire burette. You really don't want to do that because then you're going to have to add the burette again, and it might give you that workbench full message, which you don't want to deal with. And so you're much better off just removing the liquid in the burette. And so now you can see there is 2.2 ml of liquid in this burette now because, right, it's counting this part of the solution that's under the gradated part. But if you remove the liquid, now you're at 0. And so you can refill this with what you have left here, or you can just take another flask from the stock room of the 0.01 molar sodium hydroxide. And you could do the titration again if you want, if you think that you can get better data, or if you missed some points for some reason, you can do it again. The next part of the experiment is, of course, to do the same titration or the same type of titration with the base. But for that, I wouldn't recommend removing any of these things. What you can do is just go to the File menu and add a new workbench. And now you have a new bench top. And what you can do is, I'm not going to go through the whole thing because you get the idea of what you have to do, but you can put your unknown base, and now you have your unknown base, and you can get all the other material you need. One very important thing is, and then you can go back to the other workbench. So just keep in mind that you can't save this data. And so if you hit accidentally a back button or refresh or something, all this data or all this work will be lost. And you will have to do it all over again if you didn't finish, writing down all your results or data or whatever. I mean, you should be doing it as you're doing that titration, but in any case, just remember not to hit the backspace or the refresh buttons because all this work will be lost. But then once you've completed the first titration and then you get the data for the second titration, you can now go and plot your graphs. So what I'm going to show you now is some old data that was plotted by a previous student. And so this is your average titration curve for a weak acid. And you see that you have on the y-axis the pH, and on the x-axis the volume of base, the sodium hydroxide in your case that was added. Now this is not the data for this experiment. This is data from a student's experiment, an old student's experiment. And so what I wanted you to see is the way this curve works. Notice that when we start a pH, it was around 3.3, right? In the beginning, as we added, we went by 1 milliliter increments. The pH increased by some amount, some like a 0.4 pH units. And as we kept adding by 1 ml increments, the pH increase by less and less, right? The amount of units that the pH is increasing by seems to be decreasing and hardly increasing at all here, which is what we were seeing, right? The pH was increasing by a factor of 0.05, 0.04, right? And this region right here. That is because this is called the buffer region. And so in the buffer region, what is happening is that you have now you have your weak acid, but you're adding your strong base, and what you're accumulating is a concentration of weak acid and its conjugate base. And remember that when you have some concentration of both the acid and the conjugate base, you are creating a buffer. So what is indeed happening is that the solution is buffering itself in this region. And remember, the purpose of a buffer is to not have the pH increase by drastic amounts, right? And so at this point, the pH in this buffer region, the pH is not increasing by much, right? Very small amounts, but the capacity of the buffer is going down as we're adding more base. And at this point, the buffer has reached its capacity. It's no longer able to act much as a buffer. So the pH is going up by by larger amounts. And so that's why it was necessary to decrease the volume that we're adding, because what we're trying to do is get as many points as possible in this region in order to continue this curve. If we had gone by 1 milliliter increments, so notice that 1 milliliter increment, so let's say we're here, 1 milliliter would be here, and so we would jump from this point to this point, and we would be missing all these points in between in this region, right? Which we don't want to do. We want to get as many points in this region as we can. Now, in this region, in this jump, you will see that midway, the midpoint between these two highest regions is your equivalence point. Now, remember that the point of the experiment is to determine the pKa of this weak acid, and so what we need in order to determine that is the half equivalence point. So from the equivalence point, we can get half the equivalence point. But what is a better way, right? Rather than eyeballing it, because you can eyeball this and determine that, well, it looks like the midpoint of this jump is around here, but can we do that in a more accurate way? And so the best way to do that is by drawing a tangent to this buffer region, mainly by extending this buffer region straight out, and the common ion region also straight out, and taking the distance between these two lines, right? And midway through that distance would be the equivalence point. And that is a much more accurate way of determining what the equivalence point is. Of course, once you have the equivalence point, you can get the half equivalence point, and from the half equivalence point, we can get the pKa. So that is it for this experiment. I hope the video was informative. Let me know if I missed anything. But thank you, and I will see you in the lab.